Okay, this is the P4 paper from January 2023. It's question number 9, which is a proof by contradiction question. It breaks down into two parts. The second part should look fairly familiar to us. We've got questions like this in the textbook, where it's square root rather than cube root, but it should follow through a similar pattern. Part A is interesting though. What they're doing is a proof by contradiction, but they're starting the proof off for us. So let's just have a quick reminder of what proof by contradiction means. What we're asked to do is we're asked to prove that if p cubed is a multiple of 3, then p is a multiple of 3, which is true. So how am I going to do that? What we do is we actually assume that the opposite is true. So we assume that we can have p cubed being a multiple of 3 and p is not a multiple of 3. And then when we know that's not true, when we follow through a logical argument to that, we will get to a contradiction here. We'll get to something that doesn't work. If that doesn't work, then this assumption is false. And if the assumption is false, the assumption was the opposite, then logically that bit must be true. So supposedly a student has already started this. Let's see what they've done. They've said, the question was, if p cubed is a multiple of 3, then p must be a multiple of 3. So they've done their assumption and they've said, if p cubed is a multiple of 3 and p is not a multiple of 3, they've looked at the scenario where p is 3k plus 1. So they've taken that fully through and shown that it doesn't work under those circumstances. So if we can now show that it doesn't work for p equals 3k plus 2, we'll have considered all the possibilities there, and then we'll be able to finish off the proof. So part A. Following their language through, they would then say, I would then say, let p equals 3k plus 2, where k is a natural number. I'm just trying to mimic what we've got going on here. We would then do p cubed, which is going to be 3k plus 2 cubed, which is, I'm not going to do this, but it's 3k plus 2 times 3k plus 2 times 3k plus 2 and multiply it all out. I've already done that just to save myself a little bit of time in the video here. So that works out to be 27k cubed plus 54k squared plus 36k plus 8. And what I'm hoping is that that doesn't work out to be a multiple of 3. Then I'm sorted. So we just need a little bit of tidying up of this last term here. All the other terms are multiples of 3. So that's a multiple of 3. That's a multiple of 3. That's a multiple of 3. And what I'm going to break the 8 down into is 6 plus 2, because then what I can say about all of that is I can factorize and take 3 out of all that part there. So if I now do that, 3 comes out 9k cubed, 18k squared, 12k plus 2 plus 2. I've now got 3p plus 2. I've got something which clearly is not a multiple of 3. So what this now shows with those two bits together is that the assumption is false. So I can now say, therefore, my assumption is false. Remember, my assumption was that bit there. And if the assumption is false, then I can now say that that bit is true. And I tend to copy that bit out pretty much word for word. So therefore, if p cubed is a, just take my time with handwriting, multiple of 3, then p is a multiple of 3. Okay, so that's an interesting part A there, slightly different from our standard ones, but part B is very similar to questions that we've already done before, or hopefully that you've already done. What are we trying to prove? So we're trying to prove that the cube root of 3 is an irrational number. So my assumption, my part here, is going to be the opposite of that. I'm going to assume it's not, I'm going to assume it's a rational number and then see where we go and where the contradiction occurs when I try to do this. So let's say what my assumption is. Assume that the cube root of 3 is a rational number. We know that's not true. It's a rational number. And then, only because I've done these questions before, P over Q, where P over Q is in its simplest form. For those of you who remember this question, what we're actually going to do is when we do this, we're going to show that these two would be able to be cancelled down, and then my assumption is not true. But let's have a go at actually doing it. So when we do these, then we say, okay, so cube root of 3 is going to be equal to P over Q. Let's get rid of the cube root, so cube both sides. And I'll get 3 is equal to P cubed over Q cubed, which means that P cubed is equal to 3Q cubed. So this means that P is a multiple of 3. Okay, well, if P is a multiple of 3, then what I can say is P is equal to 3K. And so I can say 3K cubed is equal to 3 cubed, which means 27K cubed is equal to 3 cubed, which means that Q cubed is equal to 9K cubed. So what that shows me is that Q is a multiple of 3 as well. And there's our contradiction. If P and Q are both multiples of 3, then P over Q is not in its simplest form. So that was the contradiction I was looking for. So therefore, my assumption is false. Which then means that my original thing is true. Therefore, and I was trying to prove that the cube root of 3 was an irrational number. Handwriting's awful, I apologise. Is an irrational number. So that proof there, if you've done the ones in the book, then that's almost a very, very similar method, at least, to doing it with square roots of square root of 5, square root of 2 and stuff like that. So yeah, not a bad question to finish off on, in that, yeah, first part might have caught us out a little bit, but that second part, if you've worked hard, that should be a good 5 marks for you. Okay, hopefully that all makes sense.